This video will be the first in a series of videos on electrochemistry. For this first one, I'm going to discuss how to identify the oxidizing and the reducing agents in a redox reaction. So in all redox reactions, you have species that are oxidized, and then you have species that are reduced. Now, what does it mean to be oxidized versus reduced? So if you're oxidized, you increase oxidation number. While if you're reduced, you decrease your oxidation number. Another way to think about it is something that's reduced gains electrons, while something that's oxidized loses electrons. So that's another way to think about it. All right, so let's say we have the following reaction here. Zinc solid plus 2H plus aqueous gives us zinc 2 plus aqueous plus H2 gas. So we should start off by calculating the oxidation number for each of the species in this reaction. All right, so for the zinc solid, our oxidation number is 0 because we're in elemental form. So if you need a refresher on how to calculate oxidation numbers, you can check out the video on calculating oxidation numbers. All right, the H plus. Next. H is going to equal plus 1. In this case, H is the only atom, and its overall charge is plus 1. So that means the oxidation number of hydrogen also must be plus 1. So the same is going to apply for the zinc 2 plus now. The zinc is going to equal plus 2 because the overall charge of the cation is plus 2 and zinc is the only atom in it. And then H2, the hydrogen is going to equal 0, again because we're in elemental form now. Remember, hydrogen is one where the elemental form is diatomic, just like oxygen, nitrogen, chlorine, fluorine, bromine, iodine, all of those. Okay, so we can split this now into two half reactions based on what the oxidation numbers are. And I'll go to a new page for that. So we have zinc solid yields zinc 2 plus 2 electrons. Right, I have to lose 2 electrons to go from something with a 0 oxidation number to a plus 2. Then for the hydrogen, my half reaction would be 2H plus 2 electrons gives me, mark the state, H2 gas. So this is the oxidation half reaction, and this is the reduction half reaction. Now the last thing I want to discuss with this is, okay, we figured out what is being oxidized and what's being reduced. But there's another term that you're going to encounter, and that is oxidizing agent, and then reducing agent. This is where sometimes people get a little thrown off. The oxidizing agent is actually the species that is reduced. So in this case, the oxidizing agent is H plus. So the reason it's called oxidizing agent is because when the H plus is reduced, that causes the zinc to be oxidized. Right? You can't have an oxidation without a reduction. So when the H plus is reduced to hydrogen gas, that oxidizes zinc to zinc 2 plus. Likewise, the reducing agent is the species that is oxidized. So this case, that's zinc solid. Again, it's the reducing agent because when zinc is oxidized, that causes H plus to be reduced. Right, so I get that these are confusing, but they're going to come up a lot. So just try to remember, what does it mean when it's the oxidizing agent? It means that it is reduced and it causes the other thing to be oxidized. Okay, so in my next video on the electrochemistry, I'm going to discuss how to balance a redox reaction because the rules for it are different than just for a normal balancing of a reaction.